Welcome to Incremental Modernization, the successful approach for COBOL application modernization. My name is Venkat Pillay. I'm the CEO and founder of CloudFrame, and I'm glad you're here to join us today. Alison Levine, she's one of my favorite motivational speakers. And I remember when she talks about going to Mount Everest, I feel like very similar to a mainframe modernization. And I'll explain in a minute why. Because she said, when you go to Mount Everest, you just don't go to the summit right away. You can't run and go there. It's not possible. So go to base camp 1. If you're a mountaineer, you would know. You have to acclimatize yourself, come back, go back to base 1 again, do that couple of times, go back to base camp 2, acclimatize yourself, come back, and eventually you're very close to summit at the end of your journey. You can see the summit, but you still can't run and go there. Every step you take requires 5 breaths. Only thing you can focus on is the immediate step, because if you look at the summit, you're going to get frustrated that you're not reaching there. It's the same thing that goes with the mainframe modernization. History tells us that majority of the big bang modernization projects fail. They're too risky, and this is the reason. They're all trying to get to the summit, run to it, the shiny objects that they see. People have come up with a data-first approach. That isn't the answer. And the reason it's not the answer creates a lot more problem than solves it. And if you take a look at the statistics, 74% of modernizations fail. And nearly close to 90 to 99% of them are delayed. And the reason for this is everybody's looking for getting to the target state and doing it too quick because they have to justify it to their business. So why is it so hard? Well, let me take one example. If you take a look at, I don't know how many of you are noticing that these days, everybody's trying to figure out what's the best way to get to the carbon neutral an environment, how to reduce the carbon footprint. So people are designing new planes. And if you take a look at the new design of Airbus A350, it's a V-shaped plane. Why is it hard? And the reason it's hard is the certification. The number one thing that's important to a plane manufacturer for airlines is safety. And if you design your plane where the fuselage is not cylindrical, you cannot get safety certification because all the certification are geared towards cylindrical fuselage. Same thing with mainframe modernization. If you're going to do too many changes at the same time, you're going to change your data logic from VSAM, QSAM, BSAM, and go to the real graph database or a NoSQL databases. You change your logic to modern language. You become cloud native. You're going to realize the more closer to the target state you want to jump to, your certification becomes harder. Your business won't be able to certify it. You add a lot of risk. So the risk is because of many reasons here, because your business business people are used to certifying the results that they are seeing from your COBOL application. Let's take a simple example, interest calculation. It's a compound interest, simple calculations, no big deal. You run that in COBOL, you run that in Java, you're gonna get different answers. So all right, here I use double. You might say doubles they're floating point, they don't have the same precision. How about use java.bigdecimal? Still your answer is not going to match. And if they're not going to match, you're going to come back with a question, who's right? Well, it's not the question of who's right or wrong. It's the question is your business is used to the answer that was provided by your COBOL application. And for them to certify, they need to have a similar answer because their business processes might have changed, but majority of the logics are carried over. That's why it's so hard. Your risk certification, your business validation is really hard. The closer you want to get to your target and state architecture. Same thing with the data. You change your entire VSAM data, which was in EBCDIC, backdecimal. The data which was in the mainframe formats and the way the mainframe was using it. And you completely change the schema, you change your logic, you change your data, it will become a lot harder for you to certify. So everybody talks about radical change, but actually the radical change is actually radical thinking. The way you want to modernize is do an incremental modernization. And incremental modernization means you should be able to do everything differently. Think about if you have 6 balls you want to juggle, the chances are one of them are going to fall. And that's what the mainframe modernizations are. You have too many things going on there. You have your logic, you have your data, you have interdependency, you have job schedulers, you have triggers, MQ triggers, CICS transactions, TDQs, everything. Moving everything in one shot, it's a big bang modernization, adds to tons of risk. Start moving your logic. Make sure your logics are validated. Start moving your data. Make sure your data is validated, the schedulers and everything else. A self-directed modernization should be done at your pace, your investment, and should show up clear and concise success. So the incremental modernization is an approach to modernize COBOL application by executing a series of concisely defined control projects where you're increasing the complexity and scope. I will show you how. If you take a look at the stages of transformation, if you take a look at the way it is on the mainframe, your current state, everything is tightly coupled. Mainframe is a big, massive server. Your data is there, your logic is there. Everybody's application is on a single mainframe. All right, it may be sysplex, but it's still, to you, it's one mainframe. It's tightly coupled. Your COBOL program is monolithic program. You have file control section, you have file sections, you have your SQLs, your CICS, everything is defined as, let's say, 100,000, 200,000 lines of COBOL monolithic code. You have to start thinking how you can do decoupling. Start with a loose coupling. Start thinking about dependency injection, aspect-oriented programming, where you can start injecting things from outside. What it will give you is it will give you an approach that will make you ready for getting into your target state, which is where you want to be. You want a cloud-native application. You want an application where you follow the 12-factor app principles. And this is what we do at CloudFrame. CloudFrame, we automate the whole thing for you, but we give you an approach where you can move at the pace you want, modernize at the pace you want, save money, use a self-modernization, show your business nothing is broken. And you see here is a lever, the slider that you can slide it at your pace. Start with shifting your logic. Maybe start with batch, maybe start with CICS. But when you shift the logic, it has to be backward compatible. It means you should have an ability to go back in case something falls, a fallback. And as we said at the beginning of this presentation, back out is not same as going back. So moving your data is in ABCDIC format, it's in pacdecimal format, and it also had interdependency. You might have hundreds of applications that are using the same VSM files. You may not be able to move every application at the same time. In fact, unless your modernization project comes from the top layer and a big bang, the whole new transformation for entire company, it's going to be difficult for you to move everything in one shot anyway. If your application is dependent on a data that's given by another application, there is a silo here. So how are you going to remove that dependency? How you can be loosely coupled at the same time validate the result without impacting them? So that's the slider that you can slide using CloudFrame, where you can go at different pace. Shifting your schedulers and triggers, you have your batch jobs, you have MQ triggers, you have CICS transactions, you have a lot of things going on your mainframe, IMS, messages are coming in through DB, DC, and everywhere else. I have worked on too many companies where I have seen they have bad job schedulers where they know these jobs are no longer used. Removing those no longer used job is such a risky thing. People tried to do it, they failed, and they put a dummy job in there. I know an organization that has 25,000 bad job in a scheduler, and out of that 20,000, about 5 to 10,000 are dummy jobs because they're afraid to remove the scheduler dependencies. And imagine just between on the mainframe itself, they're afraid to remove the scheduler dependency. How difficult it is for you to move completely in a new architecture to the target state in a cloud. It's too risky. So what you want to do is start with shifting the logic, shift the data, shift the scheduler at a pace where you have a backward dependency. And in the end, you will be able to get out of complete mainframe dependency. And that's what we show you. You start thinking about the data view next. So because you haven't changed your data format, even though your data might be in the cloud, start thinking now how you're going to create views on data where you can have NoSQLs, graph database, cloud data stores, and eventually you'll be able to get out of your legacy data format. But in the self-directed modernization approach, you're validating at every step, and you're getting to your target state you know you're going to get, and you can justify the investment on this modernization approach. So let's take a quick recap of what we see. It says we can shift the logic, we can shift the data, we can shift the schedulers, we can shift the views, and CloudFrame will give you a very automated approach, a very planned approach where you will be able to get to your target state. So what are the characteristics of incremental modernization? Your scope has to be concise. You have to be very clear. Your modernization source and outcomes are well defined, because many a time I see people come up, people get excited. They look at the shiny object on the target state. I talk to many architects in many companies. They're very ambitious, and they're rightly so. They are the visionaries. They want to get to that state. But in that enthusiasm, they forget the difficulty and practicality of the problem. They want to boil the ocean, and they want to take everything together into the target state, which is a really hard thing to do. And that's where most of the mainframe modernization failure starts from. You have to have a clear success criteria, clear success definition. Success is easier to define when the scope is concise. Shorter project duration. It should be in months, not years, because if you're going to go back to your business and you're going to say, I'm going to do a mainframe modernization, and by the way, it might take 3 years, maybe 5 years, maybe 10 years. It's going to be really hard for you to get the funding. Even though your business is changing, your core business requirement remain the same. And don't expect that during your 3 to 5 years of modernization, your business requirement and data definition hasn't changed. So what you started out with an assumption is no longer be the same assumption the longer your project runs. A lot easier for you to run a shorter project duration where you can validate the results and then recalibrate for the new business change and new business environment. It reduces your risk because you want to reduce the blast radius of the change, confine it to a very smaller scope, smaller budgets. It's cost less for your project to do an incremental approach rather than going to the business, showing them the big picture, getting everybody excited, and then failing a few years down the line. So where do you start? Start with the shift logic. And I gave you an example in the beginning of a calculation. And I've seen more often than not that your calculations are a really big problem because the mainframe calculations are done differently. And they not only depend on the logic that you have in the program, they also depend on a lot of other factors. Whether you have compiled with a different compiler option. For example, if you are a mainframe person, you would realize that compiling with trunk bin, trunk op, trunk std, numproc pfd, a different type of compiler option, even your reports with ADA, no ADA, and many type of different compiler option can change the output of your results. In order to handle all those complexity, it's really difficult. If you want to do everything on manual coding, you need experts on both sides who can understand and validate the result. And this is where CloudFrame can automate this step for you, give you a clear, concise logic that your other side, the modern application programmer can understand, yet understand the rule, why the calculations were done that way. And at the end of your trillion record summary report, your answers are exactly the same you got from mainframe. So your certification is easy. You can go back to your business and say, here's your report, the performance portfolio, for example, that looked for you yesterday, and it looks the same today, even if you modernize it. Because no business is going to accept the result. Even if it changes by a few cents or a few dollars here and there, it will not be acceptable to them. And nobody can certify that you are right in a modern application or you were right in COBOL. Like I said, it's not about right or wrong. All the business risk certification validation were done based on your COBOL logic. So how do you lower the cost of your operations? What IBM has done is they've created a new engine called Zip Engine. And it's really a gift to everybody because it allows you to run cheaper capacity on the mainframe, 90% cheaper sometime, depending on it, or even more if you can utilize it. The problem is you have no ability to influence what runs on a zip. It's decided by the operating system. Except IBM says that if you use Java, your 100% of your Java workload is zip eligible. And using Java has one more advantage, and Java is platform independent. So I get it, you might have an ambition to go to .NET or Python or any other language. But if you want to do an incremental modernization, it will be a lot easier for you to move your logic from your existing legacy application to Java, especially Java on Z, because your data is there, you have data gravity, you have independence. What it also does, you can certify your logic change. And if you know your Java works on mainframe, firstly, it reduces your risk, gives you cost saving because you're using zip, and it gives you confidence that when you move to your cloud, your logic will work. Also self-fund your modernization depending on how your the mainframe cost is structured. It could be immediate cost saver, it could be cost avoidance because you can increase your mainframe capacity at a cheaper rate using more zip rather than using more general purpose processor. And that's the approach CloudFrame provides you to get to. So we talked about, we'll talk about data. We'll talk about how we do our logic shifting. So we introduce a lot of machine learning. What we do is, in the past, if you go back, look at all the companies that started mainframe modernization during Y2K time or before, they were all focusing on lift and shift. They said, we can save you a lot of money just by lifting and shifting. So it doesn't matter whether your code is crappy or your code looks like COBOL, or people were more worried about cost saving. But today, if you see more and more organizations are saying, I'm not going to take it. I want something that's manageable. I'm going to want something that fits on my DevOps pipeline. I want something that's more readable, manageable, maintainable Java, cloud native Java. So how do you get to that approach? It's really difficult for you to do it if you want to do it manually. You can put a factory assembly line approach. You can put a lot of consulting people behind it. You're still going to find it difficult to get to a target state in time and in budget and without risk or less risk. So what CloudFrame does is CloudFrame scans through and it does a pattern recognition. It uses a lot of machine learning classifiers, algorithm, figure out the patterns. And more patterns CloudFrame is recognizing, and more we go through, better the output becomes. The code that gets generated becomes a lot more meaningful, a lot more readable and maintainable. And that's how we maintain the quality of the code that gets out of it during the mainframe modernization. But also very flexible approach. And we also provide a lot of customization. So we actually allows customer or our partners to customize the output that comes out of the CloudFrame in a way where they can customize to the customer's environment without changing the base code on the CloudFrame. And that's really important because every organization you go, you're going to have some customization requirement when they move to the target state or closer to the target state. And what's also important is the test cases. So you don't really have a test cases, or maybe you have a test cases on the mainframe, but when you go to your distributed side, or when you go to the cloud native approach, when you go to the DevOps, everybody wants to have test cases. And you might find there might be organization, there might be software that can create automatic test cases for you, but those test cases are really crappy, really difficult to maintain because they don't understand your data. And since they don't understand your data, they generate a JUnit test cases, which is very hard to maintain. On the other hand, the CloudFrame has a learning process. As you go through this code conversion, as you go through the analysis, CloudFrame will generate a meaningful JUnit test cases for you. And that's really important because when you go to your next step, you have something you can back up. You have a fully developed test cases that you can start maintaining as part of the future maintenance of your new application. Shifting the data. So that's another big problem I have seen where people get too enthusiastic, they get too excited, they move everything, and then they have a real problem validating the data. And this is where CloudFrame recommends a hybrid approach. And CloudFrame provides you backward compatibility to mainframe data sources. What it allows you to do the certification, validate your data at every step, and then eventually move to your cloud data sources. This modernization goes at your pace. If you have an application and you try to change 100% of the application, it's a lot harder Then when you change 90% of the application, 10% of the application, which really matters to your business, where you want to be agile, and 90% of the application, you can say, I can do it over a period of time and define a timeline for them. A hybrid approach really works. And we have seen it in every one of the customers we have done modernization using CloudFrame. It's always been a successful approach. So validating at every step is really important. You have to have a direct comparison to begin with a mainframe and your Java. You have to have a risk mitigation. That means you should be able to go back to the state where you came from in case there is a problem. Without that, nobody will feel comfortable. That's what we are good at, addressing the elephant in the room. So then you start thinking about how do you reduce your dependency on the mainframe. We talked about the schedulers and the triggers. And they are one of the hardest part. We've gone through organization, there are hundreds and hundreds and thousands of MQ definition, for example. And then they had hundreds and thousands of bad jobs. There are CICS triggers coming through, either through MQs from TDQs for 3270 transactions, or they're coming directly from Kix web support, things like that. Now is the time you start thinking about how you're going to start your scheduler and move it into more cloud native approach. For example, if you want to go to your scheduler, you want to move from CS7 and you want to get into Apache Airflow, for example, you have to make sure there is a way that they are backward compatible. And also there is a way you can do it in a hybrid fashion where you can move some or all or a portion of it into your new scheduler from your mainframe existing scheduler. Because you're going to find that the things are not as clean and clear cut because they were done for last 30, 40 years. You're going to find a lot of hidden surprises. This happens invariably 100% of the time. There are hidden surprises. I have not seen an implementation where people have done a mainframe modernization and they thought everything they knew ahead of the time. It doesn't work that way. So think more and more hybrid approach, think incremental approach. I think the minimum viable product allows you to go safely and get to your target state. Even if you do a big bang approach, if you plan for 5-year approach and you say 5 years is too long, but you're adding too much of risk, but in an MVP approach, you might still take the same amount of time, but because you're validating your results at every step of the time, it gives you a lot of risk mitigation. And it also allows you to do a self-directed and self-funded modernization. And we can show you at the CloudFrame. So now the last step is you start thinking about how do you remove your data format dependencies. So CloudFrame allowed you to have a hybrid approach where your data may be on the mainframe, data may be in the cloud, but it was allowed to be in the mainframe format, AppCity, pacdecimal, COM, things like that. Start thinking about CloudFrame will allow you to create the view where you can start moving your data into views of graph databases, key values. And because we talked about in the beginning about the dependency injection and loose coupling, you will be able to take things apart and start plugging new version of your data views into your Spring Boot, Spring Batch, or any of these aspect-oriented programming framework and not change your logic initially, because some of those business logics are really critical to your business. And that was your last step. It will allow you to get to your final stages. Sometimes people get to the target. They don't call this, still don't call it a cloud native and 12-factor approach is not their target state. They probably want to redesign it. They want to think cloud native first. They want to get to a completely different approach, redesign schema changes. But like I said, you don't have to do it to the 100% of the application. You can do it where it makes sense for your business. And it still be a modern application that fits in your DevOps pipeline, something that can be maintained by a person who has no mainframe experience. It can understand the new logic. It's cloud native and it follows the 12-factor app principles. So the summary of all the articles we have done so far is you transform at your own speed. You also think of the self-funding modernization where you don't have to go back to business asking for money because you save so much of money that the money you saved can be funded back, routed back into your modernization activity. think of backward compatibility, reduce the risk, continue to use mainframe data sources, and then start thinking about creating a views on it so it becomes more modern, and eventually you get rid of the dependency to the mainframe. So it's a progressive movement where you start hybrid and you get to the cloud data sources. Yeah, so we talked about the loose coupling, we talked about dependency injection, we talked about aspect-oriented programming, and we felt that Spring Boot, Spring Batch, Spring-based applications are really good framework. And the reason it's a good framework is because it pretty much gives you everything out of box. It's well proven, it's been there for a very long time. It also allows you to package your application into cloud native approach. They can easily convert your legacy. I mean, there is nothing easy, but if using CloudFrame, you can easily convert it into 12-factor app principle. It makes it DevOps ready. Because CloudFrame will also provide you JUnit test cases, it reduces your risk because now you know how to, when you make changes in the future, when you have completely cut the cord on the mainframe side, it becomes easy for you to maintain those test cases and check any changes you're making. Because earlier you may or may not have a test cases, and you're getting into a state where you are much better in your DevOps pipeline, where you have all the DevOps principles followed, the code qualities, the test cases, and everything else. So those are the key benefits of using CloudFrame. So CloudFrame is just a pure software. It can be used directly DIY by the company. It can also be used by our partners, who are many of the systems integrator consulting company. They love to use it, and the reason they love to use it is because it gives them a great deal of customization. It also gives them an assurance that they can get to a successful implementation for their customers. And there are a lot of benefits of using CloudFrame, an automated approach, rather than going through putting a lot of effort figuring out what was done in the past, rather than taking advantage of machine learning. And you might still make a mistake, and you might still have a problem certifying the data and the validation, which adds to your risk, and also the cost factor.
Thank you. Take care and be your best.